Welcome, and thank you for taking the time to watch this presentation.
For a century, the final mile of commerce has been dictated by one unforgiving surface: asphalt. Every day, multi-ton delivery vans burn time and fuel idling in dense suburban gridlock. We deploy thousands of pounds of steel and lithium-ion batteries just to move a bottle of aspirin or a paperback book down the road. Autonomous aerial delivery offered a way to sever this tie to the ground. By routing packages through the open sky, logistics networks could bypass surface friction entirely. When the concept first captured public attention in late 2013, the timeline felt imminent. But operational physics meant these systems spent a decade locked in isolated test fields. Early prototypes collided with three stubborn barriers: an acoustic whine irritating neighborhoods, hardware that failed in rain, and a strict federal bureaucracy unequipped for automated low-altitude flight. Engineering an aircraft to carry a box was relatively simple. The actual challenge was designing an infrastructure layer that could operate safely and quietly above densely populated backyards without constant human oversight. Amazon's response to these physical constraints is the Mk-30, a hybrid vertical takeoff and landing airframe that marks the transition from prototype research to a hardened commercial system. The first mandate was securing neighborhood acceptance. That meant eliminating the aggressive, high-frequency rotor whine generated by early quadcopters. Engineers developed specialized asymmetric carbon fiber propellers designed specifically to manipulate the aircraft's acoustic profile, cutting perceived noise volume by 40%. They disperse the remaining acoustic energy into lower, broader frequencies that blend into ambient neighborhood soundscapes. But sound was only half the equation. Touching down in dense yards exposes high-speed rotors to unpredictable environments filled with furniture, pets, and children. To mitigate this risk, the hardware abandons the low-altitude landing model entirely, replacing it with a precision motorized winch. The aircraft now maintains a stable hover 15 feet overhead, keeping rotors clear of obstacles, while a tether smoothly lowers the parcel to the grass. By hardening the chassis against rain and silencing the rotors, this iteration moves the drone from a disruptive mechanical nuisance to an unobtrusive utility. Yet the most advanced airframes on Earth remain grounded if aviation authorities block their flight path. Under legacy regulations, commercial operators were forced to station human visual observers along every flight corridor. Relying on people to spot individual drones mathematically destroyed the cost advantages of automation. The entire program hinges on Beyond Visual Line of Sight, or BVLOS, approval. This critical inflection point makes aerial logistics economically possible. Approval required integrating stereo vision, thermal, and optical sensors. These feed into detect and avoid algorithms, mapping power lines and air traffic in milliseconds to automatically evade them. Offloading the visual monitoring to redundant software processing breaks the strictly enforced 1-to-1 ratio of pilot to aircraft. With human spotters removed, a single remote operator can now monitor dozens of simultaneous automated flights through centralized airspace traffic feeds. Clearing this regulatory hurdle allows operators to stop flying isolated novelty routes and begin deploying highly integrated automated fleets. Even with airspace clearance, the goal of this infrastructure is not to replace the traditional ground delivery fleet. Instead, the logistics network splits into a multi-tiered grid, routing packages through different transport modes based entirely on their size and urgency. Heavy bulk freight, oversized items, and standard timeline orders remain highly cost-effective moving across asphalt inside electric vans. Meanwhile, highly urgent cargo, like specialized medications, daily grocery essentials, and packages weighing under 5 pounds, are routed upward into the unobstructed airspace. These two tiers operate concurrently out of existing same-day fulfillment centers, maximizing dispatch efficiency by letting ground and air units handle exactly what they do best. By matching the payload to the precise transit mode, facilities can reliably execute 30 to 60-minute delivery windows across sprawling metropolitan hubs. The ground fleet and the aerial swarm do not compete. They synchronize to handle different extremes of the supply chain volume. By engineering a quiet aircraft and securing federal airspace integration, the century-old ceiling on last-mile logistics is finally open.